Good morning to all. In continuation to the previous two lecture, today I'm trying to explain the theory of Newton ring which help us to the formation of the understand the formation of Newton ring. Please, in this section, a theoretical formulation is discussed on the basis of the wedge-shaped thin film conditions. So, to understand the theoretical aspect, I advise to all of you, please go through the concept of the interference caused by the wedge-shaped thin film. So, let us begin this. So, the formation of Newton ring are a special case of the interference due to the symmetrical air wedge shaped thin film, which is formed between the lower curved surface of long radius plano-convex lens and upper surface of the glass plate. Remember, as we discussed in the previous lecture, this is called the Newton ring assembly. Now, when a light falls on a assembly, that is Newton ring assembly, and produces the pair of coherent waves due to the multiple reflection and refraction from the air wedge shaped thin film. Such coherent waves superimposed and it results interference pattern. So the effective part difference satisfies the condition of maxima or condition of minima. If this condition of maxima and minima is satisfied by the Newton ring assembly, we will observe a ring pattern. So let us look the effective part difference condition. As you see in the effective part difference due to a wedge-shaped thin film is given as, in general, delta effective is equal to 2 mu t cos of r plus alpha plus minus lambda by 2. This is equation 1, where mu is refractive index, t is thickness of wedge-shaped thin film, r is the angle of reflection, and alpha is wedge angle. The lambda by 2 term is introduced due to the Stokes reflection. Dear all, you always remember the Stokes reflections takes place when a reflection is backed by the denser medium. And it is a very important point to note. Now, I try to apply this for the Newton ring assembly. In case of Newton ring assembly, the refractive index of the air wedge film is 1, angle of refraction is 0, and because the angle of incidence is 0. Alpha, that is angle of wedge, which is very small, tending towards 0, because value of r is effectively very large. You can say r tends to infinity. So the effective part difference in case of Newton ring assembly, equation become delta effective is equal to 2t plus minus lambda by 2. That is equation 2. In this, the effective part difference is dependent on the only value of t. Because lambda is constant, we have taken a monochromatic light. Therefore, the effective part difference is only dependent on the value of t. For a particular value of t, a symmetrical air wedge shaped thin film, delta effective satisfy the condition of maxima or minima. Now you always have a condition of maxima and minima if delta effective equals to n lambda for the bright, that is maxima. If delta effective is equal to 2n plus minus 1 lambda by 2 for the dark, that is equation 3. Due to equation 2 and equation 3, we have the following condition. So 2t plus minus lambda by 2 equals to n lambda for the bright ring and the 2n plus 1 lambda by 2 for the dark ring. Now the value of 2t equals to n lambda for the dark ring and 2n plus minus 1 lambda by 2 for the bright ring. Oh, sorry, now it is visible to you. 2t is equal to n lambda, 2n plus minus lambda by 2 for the bright ring. Dear student, we have the effective part difference, which is purely dependent on the value of t. So the value of t is a very important to compute. How do we compute? This is the procedure to compute the value of t. We have taken a Newton ring assembly where the plano-convex lens is AC dash and glass plate is OO dash. This plano-convex is resting at the point C. Now completing this sphere of radius r, let's say the center of sphere is O. To see in this figure, at the point A, where the thickness of air film is T, and we compute a relation between T and this Rn, because AE, this one, is your value of Rn. Rn is the radius of nth ring. DE, that is your this one, is RT minus R minus T, sorry, and DA is equal to this one, the radius of this sphere. Using Pythagoras relation, we have in the triangle DEA, this one, we have DA square equals to AE square plus DE square, and putting the values, we get the value of T, that is Rn square over 2R. We also know that the dn is equal to 2Rn. Under the condition the t is a very small because capital R is very large, therefore the t square is neglected. And this is the point which I wish to. Now substituting the value of 2t in the expression 4 from the equation 5, we get the relation dn square is equal to 2n plus minus 1 twice of lambda r and also equal to 4n lambda r, respectively bright and dark ring. Taking a square root on the both side, we get a relation of the diameter, which is the under root 2 bracket 2n plus minus 1 lambda r and under root of 4n lambda r, respectively for bright and dark ring. This is equation 7. The equation 7 is a condition of bright and dark rings respectively. Sorry, this was not visible. Please see, the equation 7 is this one and equation 6 is this one, which is very important to understand the interference pattern in the Newton ring case. Thank you for today. In the next class we will try to discuss the application of these expressions. Thank you once again.